Our patented adaptive learning algorithms take into account both accuracy and speed from previous trials to decide what to present next. Items that need more practice will return more frequently, creating a learning session tailored to the individual student's needs. The status of individual items is automatically monitored. This ensures that all students in the classroom will reach the same level of proficiency. These methods differ considerably from traditional methods of instruction that fail to take into account these principles. These components make possible efficient and individualized learning and assessment that are unmatched by any other learning system.
Several persistent problems impair learning in most instructional settings. Instruction usually does not adapt to meet the needs of each learner. Assessment and feedback often come at the end. Fluency of processing is seldom assessed, and learning very seldom guides the learner to mastery based on objective criteria. All of these problems can be addressed through adaptive learning techniques. And Insight's adaptive learning technology optimizes learning for the individual, embeds objective assessment, and implements objective mastery criteria. Another limitation of traditional instruction is that learning techniques fail to incorporate principles that have been discovered in scientific research on learning. There's a number of laws of learning that can be optimized if one knows about the accuracy and the speed of the learner for different items or concepts. Some of these involve the dynamics of short-term memory and long-term memory. Some involve what's called the spacing effect. One thing that really distinguishes Insight's adaptive learning technology is that it's been proven in research to be effective. Tests of Insight's technology show that it can cut learning time in half in almost any learning domain, and the mastery criteria that are tracked and implemented allow every learner to get through all parts of the learning, meaning that learning is much more comprehensive. And reaching objective criteria of learning also predicts that learning will endure. Adaptive sequencing algorithms can be applied to almost anything. In elementary mathematics, however, one of the key challenges is to get students to know both accurately and fluently the basic math facts. Things like 8 plus 5 equals 13, or 8 times 7 equals 56. All right, here we have an example of a screen in Insight's core math product. And here we see a multiplication problem, 5 times 8 equals 40. And I'm just going to put in correct answer here. Here we've missed the problem, we've gotten feedback. The magic of adaptive learning is what's happening across the trial. So remember, we just missed the problem, 8 times 2 is 16. Now I'm going to get this one correct. And notice that the computer is reporting back some response time information to the student, but it's also using that in sequencing. And let's just, for the heck of it, get this one correct as well. Now here's our 2 times 8 problem again. You may remember before it was in a vertical array, now it's in a horizontal array. If the student learns a problem here, they're going to learn it in different contexts, which will give them a more flexible understanding. But most important for what we want to say about adaptive learning is the fact that the student missed this problem before means that it had a high priority for coming back soon. Insight's adaptive learning technology is pretty complicated to explain in a short presentation. It works with proprietary algorithms that use speed and accuracy to implement a number of laws of spacing and sequencing and adjust learning for each individual, and then bringing that individual to comprehensive mastery of all the items or concepts in a learning set. where mastery includes both accuracy and fluency. We can distinguish different kinds of responses we might get. Let's say the student is incorrect in this. The problem will still have a high priority. Okay, let's look at 1 times 7. That's an easy problem. Let's say the student answers that correctly and fast. Notice that the priority the computer is assigning to this puts it well at the bottom of the stack. The intuition here is that as learning strength increases, as the student gets correct and fluent, the best time for an item to come up again is a long time later. Remember that the computer algorithms are optimizing the learning of the whole set. That's one of the features that makes this technology so powerful. So now 3 times 5 has come up again, and let's say this time the student's getting a little better on this and gets the correct answer, but slowly. Well, if it took a long time, learning strength is better than if they missed the problem, but it's still not very high. You can see that the item goes down in the stack, but will still come back fairly soon. There'll be some other problems in between. Now we'll miss 8 times 6, and that gives it a high priority. 4 times 5 comes up, will be correct and fast, and it shoots to the bottom. Well, this demonstration is very simplified in the number of items that are in play, and actually in the kinds of delays that we can show in a simple graphic like this one. But I hope that suffices to show some of the ways that Insight's adaptive learning technology uses each learner's speed and accuracy to achieve an optimal sequencing and spacing of learning items.